just to get things going while you're thinking about the question you'd like to ask, I'll just start things off with a common question for everyone, and that is the following. And maybe we can start, Mary, with you at the end. And the question is, if you had just one silver bullet and you could spend it on whatever you wanted in order to take your dream and what you talked about, to the next level or get it to, what would that be? And sort of a follow-up, given that I suspect most of the people in this room are people who are technologists. What would you ask of the, what could these people in this room do for you to help you achieve what you're trying to achieve?
Okay, good question. I would say I would start with the platform that I didn't get very much time to explain, but we have this idea about this software development platform that would take data through an API link and then could then plug into many apps or models on the other end. So it's just that operability and the software functions that would allow all that pre and post processing to occur. That's where I would invest first, because there's demand for that information, and there are lots of innovative natural and social and biophysical scientists doing really amazing models out there, and there's lots of data. So it's, to me, the first bottleneck to get rid of is the platform, the interoperability, like actually several people on this panel have talked about too. So that's her. And the help from experts in the room would be thinking about what sorts of pre-processing for either, if you're an app developer, if you're a modeler and you use that in your work, what sort of metrics and information do you need? And that helps people design the pre and post-processing algorithms. But also just if you have expertise on how do you put together such a platform. I mean, there's lots of prototypes out there. We're prototyping one, but it's a basic software engineering help and data pre and post processing to help inform your decisions is the kind of advice that I would love.
Noah?
I think I'd do what they're doing at Grow Intelligence, actually. That was pretty cool. No, I think that's actually an example of in that part of the world, in that sector of, I think what we is a real problem more broadly, that it's easy for us to say, if we had a bigger computer, here's what we do with it. If we have more storage, here's what we do with it. But really, in terms of understanding climate risk, there's a real gap where, as you heard for Africa, the level of data availability of what makes vulnerability, what's the fundamental condition. We have been really restricted to these pretty gross, like annual scale, World Bank type metrics, which are valuable. But I think there's a lot of potential to really understand a lot more subtlety, both in places like Africa, but also here in the U.S. So if we look at a city, for instance, we know from a lot of really detailed social science work that's been done that if you have a heat wave in a city, there the damages, the morbidity and mortality that occur in a heat wave are really concentrated based on socioeconomic conditions, based on the strength of community networks, and that's come out of really place-based long-term study. I think we're at the point now with search and mobile social data where we can really scale that up to assess vulnerability across urban areas based on those kinds of data. I think also we heard this morning about the home data, big data, sort of Internet of Things, and the whole home data system. And I think in terms of vulnerability of infrastructure, there's probably a lot of potential for when there is an earthquake, those sensors that are built in provide information about structures, and that potentially provides information about vulnerability of infrastructure as well. So I think we certainly can use a lot of help on the ingesting those data, the algorithms for analyzing those data. I think also how we determine what vulnerability is based on those data. So those are some thoughts.
So, like I said, we're the youngest, so we can use the most help. I think for me, you know, the silver bullet now lies in actually going through that third layer I talked about, which is really building the computational capabilities to a level where you're doing all sorts of predictive analytics. And that's, you know, a people problem. When I started the company, I moved to Kenya for two reasons. It had open capital markets, and it probably had one of the most advanced technology infrastructures in Africa. And so I was hopeful that I would find the talent I needed to build the tools we wanted to build. And as I discovered the type of data sets we were going to use, all I had was a defined problem when I went there. When I discovered the types of data sets we were going to use, it quickly became apparent that the talent actually doesn't exist there, unfortunately. So we just opened an office in New York as a way of addressing part of that problem. So, you know, I think for us, the silver bullet is more people. It's really, you know, we've done a lot of the hard work of going through the discovery process and figuring out how we want to go about cracking the problem. We just need more people excited about the problem, thinking about the problem, giving us ideas, and I think that will get us there.
Yeah, I mean, so for me, it feeds off what Sarah just said, which is maybe one level up and, you know, on a more diversified scale, it's products. So the biggest barrier to applying technology to solve, you know, problems like the one that Sarah's addressing is that you don't have teams on the ground or companies in these markets that know how to build these products. They don't even know where to begin. And so it goes, you know, it goes beyond even just talent. And, you know, Sarah opening an office in New York is a reflection of that. I think, you know, you're not going to see, in my opinion anyway, you're not going to see the local teams and the local knowledge and the local context emerge. And so I think increasingly the way that the world is going, you do see these pockets of expertise. And because of where communication technology and everything else is going, you can access these different, you know, pockets of expertise to address problems that are not local in nature. And you started to see that with, you know, India and outsourcing and China and manufacturing and everything else. So I think one of the things, you know, for you guys and that we think through, I'm thinking through a lot right now with Sarah and everyone else, is how could you actually more efficiently build products so that you're not just sitting there waiting for the talent and everything else on the ground to emerge, but you're tapping into, you know, people here, companies here, an ecosystem that knows how to build products, but pairing it with the local expertise and knowledge that enables you to build products that actually address the problems that need to be solved. Because, you know, there's a disconnect if you just sit here in a vacuum and try to write algorithms. So.
Good. So Snare has the microphone. Yeah, let's start right here with Joe.
So this isn't a big data question, it's little data actually. It's for Sarah. So you mentioned the silver bullet. I was thinking the silver bullet for Africa, as far as I can tell, was a little data problem in that women's education is the fundamental problem. And if you correct that, a lot of great things flow from it, like reduced birth rate, more entrepreneurship among women who are liberated from their masters and all that. All these great things follow. So do you see that as not a stumbling block, but as a precursor to all this other investing that you'd have to do to set the seed, as, you know, educate the women? Because see what's happening in Nigeria right now. So is that even a precursor in your mind?
So I guess Jeff, in his introduction of me, briefly mentioned I was a trustee of the Mandela Institute, and that's, you know, on top of my girl hat, I wear this activist hat, and that activism is mostly driven around, you know, basically good policy making and education, and really setting education and measuring education not by the number of people we educate, but by the quality of education we give. And particularly, we do with another organization that I sit on the board of called Truth Aid, we focus a lot on child marriage, 13-year-old girls getting married off is very common in many African societies today. And so yes, I think it's fundamental. I just have to wear two hats to address them, simply because one problem versus, one can still and needs to be cracked, because the problem you're addressing is about behavioral change, and that's just going to take time. And I think we all have to speak loud and push, but it won't happen overnight. So it's a two hat problem.
Yes, sir.
So many of you spoke about the challenges that you have with manipulating data and managing data. But in this area, today's conference, one of the issues that were not addressed was the fact that there are large stumbling blocks when it comes to instrumenting the environment and the world in general, the putting down of sensors by the millions across the globe, right? Have you guys given any thought to what would it take to instrument the world so you get relevant data, timely data, that you can actually get more interesting information from? And the reason why I'm kind of mentioning this is nobody has come to me and told me that here are some interesting sensors I would like to have to get my job done, and these sensors should cost no more than, say, 10 cents. Nobody is coming up with these kinds of requests. And these are very relevant requests, because in the day of 300 millimeter wafer technologies, getting a chip that is 10 cents is a piece of cake. But nobody is actually looking at it and asking the right questions about how do we instrument the world to actually get the data we want. And I think this is something that we need to think about. And I'm wondering if any of you have given that some thought. And if so, I'd like to kind of hear your comments. If not, if you don't have the time now, I'll give you my email address. I'm the Director for Science and Technology for IBM Research, and we're always looking for interesting challenges to help you guys do your job.
It's a great question. And by the way, if anyone in the room wants to weigh in on that, that would be fine too. But now if I gave you a bag full of, a big bag full, like as big as this room bag full of 10 cents instruments, what would you do with it? Yeah.
Well, so in terms of weather and climate prediction, certainly instrumenting the ocean is critical. And there is a network now of floats that are distributed globally, but they're very sparse. And basically they're geolocated. They submerge. They take a profile vertically, come up to the surface. That gets transmitted to satellite. They go back down, and there's that has definitely helped our predictability in terms of what we know about the El Nino that's developing right now, as one example. So that's definitely improved short and medium term range predictability. But really, what is needed is much denser network of sensors in the ocean to know what the current state of the system is, because that really ends up influencing the atmosphere. The second, I guess I would just come back to is not answering your question, but maybe inverting it, is that I think in some ways we're with remote sensing and instrumentation on land, we know a lot about the physical system. We know less about people kind of in real time, and I guess that's where my hope is that we can take advantage of some of what you're talking about, some of the devices that people are carrying around with them, to try to learn more about that part of the risk.
Yeah, Mary, go ahead.
Yeah, so we have, I agree about using cell phones. We're involved in a project using cell phones to monitor social impacts of water fund payment schemes throughout Latin America, and now just starting in India and Africa. But the physical, the biophysical, the two biggest ones that we see that would be great to have some help with are groundwater data worldwide and soil moisture data. So those two for predicting all of our crop agriculture production and all the water supply issues that people have talked about. Those are all big parts of the projects that we are involved in, and those two parameters are really tough to get in most places. So I love to talk with you about a 10-cent sensor that could help us get better data on those.
I have another request.
Go ahead.
At lunch, we were discussing this with Bill, where he asked me, are you guys going to try and do and build crop insurance models off of this? And I said, I wish. Because in the African context, unlike in the U.S., the physical distribution of weather stations across the continent is very scarce. It's very sparsely populated. And so if you just take a map of location of physical weather stations around the world and you just look at it, you'd be shocked at how sparsely kind of populated it is in Africa. But more importantly, if you then add to it one more layer, which is when was it installed, it will be like in the 1960s, basically. And so most of these weather stations aren't working. And we've looked at all sorts of ways around, bridging that gap and spent a lot of time with European companies that are currently installing some of the weather stations that are going up. And when you go through the budgets and you look at the line item put in for vandalism and theft and contingency, it's equivalent and sometimes greater than the cost of installing the actual weather station. And so I always say if we could figure out a way, and there's like a raw area and a raw space in the world today for us to experiment with sensor networks and installing all sorts of sensor networks to look at this problem. So I'll take a bag full of Tencent.
Yeah.
Craig Lewis with the Clean Coalition. A question for Mary. I was really impressed with the solution of coming up with the Flickr photos for essentially your crowdsourcing sensor network. Mm-hmm. And I also really appreciated your emphasis on the importance of a platform solution. And I was wondering if it seems to me that there's platform solutions out there for environmental data, and including from Teradx, which is founded by Bob Wenslow out of Stanford, mm-hmm. And wondered if you had thought about how to, I guess, kind of put your platform on top of some of those environmental platforms and whether there's some useful pathways there.
Yeah, that's a great point. Yeah, we've definitely been in the midst of this kind of landscape analysis to find out who's already out there with certain. We know some of them because we use them, and trying to figure out how to make them interoperable. So definitely not reinventing anything, but trying to figure out what are the big functional pieces that we could tie together through these API links. That's really the design. And all these new data, like Planet Labs that's spinning up from around here too, is really interesting. There's a lot of good, both platform and data. And so it's a matter of getting the whole soup to nuts of the flows that we see needing to create spatial maps of ecosystem service value around the world and linking those together. So that's the real challenge, I would say, not starting from scratch. Yeah. Thank you.
One last question, perhaps? Yeah.
Hi, name's EJ Ramos, grad student at Cal Poly Pomona. So my question was actually a result of the last presentation on agriculture, but maybe someone else on the panel may have info on this. Seems that a lot of the focus on the future of agriculture has been on improving infrastructure and production and the economics of agriculture in general, whether in Africa or globally. I've also read that a lot of the produce here in America isn't necessarily 100% utilized. So how do we track the waste from restaurants or maybe perishable foods that are produced from farms, large-scale farms? And has this been accounted for in the algorithms or any research?
So I can speak. I think you rightly point out that it's two different sets of problems. In the U.S., it is a food wastage, and it's a food wastage problem. It's the fact that it does get through some level of processing and it gets wasted once it's hit a restaurant, a home, a supermarket, etc. In developing markets, the harvest, actually, it's a post-harvest loss issue. It never makes it to market. So, that's why it's an infrastructure problem. It's a markets problem. When you look at the numbers around it, we actually have done, so one way in which we're building out this platform is we're actually doing work along with partners along the way. And so one of our partners is the Rockefeller Foundation. And we've spent a lot of time looking at what they're launching as their food and spoilage program, food spoilage and waste program. And we're investigating a lot of these trends. And what we found is that in certain core grains in Africa, Africa would be food secure if we simply eliminated the post-harvest loss issue. So if we only knew where crops were grown, when they were grown, and we could get to them, you would be net, basically your supply and demand balances would flatten out. So it's a core problem, but in the developing market context, it is a wastage, it is an infrastructure issue, and in the US and in Europe, it's a spoilage issue after processing. And there have been a lot of initiatives that have popped up, but there aren't, and there are big numbers that get released, but there aren't actual initiatives that I've worked with or know of in this context. But I haven't spent as much time in the US thinking about the problem.
All right. I think in the interests of giving you a break, and I think we'll stop right there. I just want to add one thing to this discussion, which I think is getting to a very interesting point. This morning, one of our speakers, Jeff said, and not surprisingly, that big data is a sort of a science and engineering challenge. And I think after listening to the panel this afternoon, I think we could add a whole bunch more dimensions to that. I didn't actually agree with him, and I'd be interested actually in your reactions, not right now, but because I think what we're seeing through this panel, that it's a lot more than just science and engineering, and I think that's what makes it so fascinating and so difficult. So let's thank our speakers once again, and we'll take a break.